Precalc, Chapter 4, Section 7. So we're going to look at the inverse graph function. First start here, we have the sine. I've already plotted some of the points we should know from the unit circle. And this is the sine wave, so it keeps continuing on in both directions. The wave, it's periodic, and so it bends. Now, so some properties about this curve is that it's not one-to-one, or another way of saying that is that it does not pass the horizontal line test. And if you recall from previous chapter, this definition is really talking about the inverse function, not this function. This tells us something about the inverse, how the inverse would not be a function. To graph the inverse, we need to restrict the domain then, because if we want the inverse to be a function, then we need to restrict the domain so it doesn't repeat. And so if I look from these 2 points, from the negative pi halves to the pi halves, if I restricted it to between those two x values, so have that be the domain, then our graph would then become one-to-one. And so we actually restrict the domain to these values so then we can have an inverse function. As we're talking about inverse functions, we really are restricting our domain. So the inverse function, y equals arc sine x, if and only if sine of y is x. So notice how the x and the y has switched, and when you do that, you have the arc. And so that's a notation saying that you switch the two variables. And so in your calculator, or you've seen in the past, you probably use this notation, sine to the negative 1 as the inverse. Arc sine and sine to the negative 1, both are meaning the same thing, the inverse function. Notice how the x values and the y values switch. So those radian measures that are usually in the x-axis are now on the y-axis. So all we do to graph is that we switch the x and the y, or we switch the domain and the range by definition for graphing inverses. So I'm going to take these x values and I'll make them become the y values. And I'll make the y values become the x values, maybe. So then when I'm plotting this on a graph, on the x-axis is actually our y values. So we have negative 1 going by halves. My y-axis are now all my x values, so I'm going to go by pi 6. So doing the same thing I just did on the previous graph, I'm just switching the axes they're on. So then if I graph these points, negative 1, we're at pi halves. So that's going to be a negative pi halves, so that's going to be down 3. At negative 1/2, we're at pi 6. We're at 0, 0 still. At 1/2, we're up to pi 6. And then 1, we're up at pi halves. So this would be the shape of the inverse. Now for the inverse function, there are no arrows. So no arrows here because we have restricted the domain. And so we only have these radian measures. And so we only have this graph. These would be end points. So it stops. So for arc sine of negative 1, if I change that into the other form, that's like saying the sine of some theta is equal to negative 1. And so it's similar to how we've done that with our log functions, how if you want to call that m, if you want to write that without the arc, these other two just switch spots, going back into the inverse. And so sine of theta equals negative 1. Where would that occur? So on the unit circle down here, our sine values are the y values of all these points. So what y value is negative 1? That's right here. And so our radian measure you see is 3 pi halves, but it's not 3 pi halves. So even though you think that theta equals 3 pi halves, this is not the answer, not the solution, because it's not in the domain. It's not in the domain of the arc sine. The arc sine, our theta, has to be between pi halves and negative pi halves. So instead of going all the way around the unit circle to get to 3 pi halves, we're going to go the other direction, this direction, to reach the same exact spot. And so the answer to this is theta would actually be negative pi halves. And so you have to be careful about how you state your angle for these inverse functions. And so arc sine of root 2 over 2 is basically saying what angle, the sine of what angle has a ratio of root 2 over 2 within the domain we have. So our domain for sine is from negative pi halves to pi halves. So in this portion of the unit circle, where is there a y value of root 2 over 2? And the only spot that is pi fourths. And then the inverse sine, so this is the same thing as the arc sine, as negative 1/2. So it's saying sine of some angle is equal to negative 1/2. And so that's going to be down here at negative pi 6. And so you have to stay within this range. And so you have to use the positive and negative angles between negative pi halves and pi halves. So arc cosine, very similar. So these are the points we can use to graph our cosine value. So at 0, 1, and then at pi thirds, so I'm still going by, we can go by, so this is the cosine wave. Now again, the issue with the cosine wave is that it's not 1 to 1, and so we restrict our domain between this value and this value. That's the portion we're going to graph. So you have all of the y values are included here. We're restricting our x values from 0 to pi. And so the values up here are really the values we're going to use to graph the inverse function. So just like we did with the sine, we're going to switch our x and our y values to graph the inverse. So let's graph the arc cosine here. I'm going to go by pi 4. So really this is like our x-axis, this is our y-axis. So 1, 0, and then 1/2 pi thirds. And so pi thirds is going to be about here. Pi halves 0, negative 1/2 2 pi thirds, and then negative 1 pi. And so you still have that negative cubic type shape to it, and these are still endpoints, not arrows. And so that's the inverse. And so arc sine of x, arc cosine of x, you should be looking at where we start and where we end. And so for the sine, this is for the sine, we go from negative pi halves to pi halves. For cosine, it goes from 0 to pi. And that's what we're showing here, is that our start is from 0 to pi to have a domain to make it 1 to 1. And for tangent is the same actually as the sine, and we'll talk about that here in a second. So sine and tangent have a similar domain for the inverse functions. And if you look at a unit circle for tangent, what our tangent values are, we are undefined. So tangent is undefined between here and then also this value undefined for divide our sine by cosine. So you're doing 1 divided by 0 or negative 1 divided by 0. So as we move along here, we go from negative infinity all the way to 0, then to positive infinity. And that's kind of what the tangent values actually do when you divide our sine by cosine. And so that would be the domain for all these possible tangent values. And so for graphing that, graphing our tangent of x at negative pi halves, we are at undefined. At negative pi fourths, we are at negative 1. At 0, we are at 0. At pi fourths, we are at 1. And then pi halves, we are undefined. So at negative pi fourths, we're down here at negative 1, 0, 0, and then 1. So we can sketch this graph. And this one does have arrows. But then when we sketch it over here, we still switch the x and the y. So these become our x values, these become our y values. And so now we have horizontal asymptotes. So we have negative pi halves to pi halves. If I plot that at negative 0, negative 1, 1. So at negative 1, we're at negative pi fourths. We still have 0, 0. And we have pi fourths, we're at 1. And then we're undefined here. And we're undefined here. So we have this shape is the inverse function. We also have arrows for it. So this is the inverse function of our tangent. So let's look at evaluating some more here. So arc cosine 1, we can rewrite that as cosine of some theta equals 1. I'll make sure you understand how to translate between these two forms. And so where is cosine 1 at? Cosine is our x value, so it's 1 is right here. That's our x value, so it'd be 0 degrees, or we should not say 360 because again cosine is only the first and the second quadrant. Inverse cosine 0, so cosine of what angle is 0, so where's our x value? 0 up here at 90 pi halves. Inverse cosine square root 2 over 2, so right here at pi fourths or 45 degrees. And then arc tangent -1, tangent of theta is -1. Where is tangent -1? So again, we're dividing our sine by cosine, so I wanted the same, just opposite. So we're over here and then here. So these are two spots where tangent is -1, but we have to recall that tangent is between these two quadrants, and so we got to say it's negative pi fourths. So this would be negative pi fourths, or negative 45 degrees. So with a calculator, we can also approximate these. Arctan of 4.84. I'm going to let you do this on the calculator. They don't have an arctan key, but they do have the tan to the -1 key. So I want you to evaluate that function for your video homework problem. So it should be a pretty easy one. So video homework problem right here. Arc sine of -1.1, so you could punch that in the calculator, or we can look at that mentally. The sine of theta equals -1.1, so where's the sine at -1.1? That's our y value, and you can look and look and look, but you're not going to find it, because we should realize that sine, the sine of theta, has to be greater or less than or equal to 1, or greater than or equal to -1. It's always between -1 and 1. And if you look at your sine wave, so a sine wave is like this, it has our y values of 1 to -1. Sine's always between those, so we cannot have an arc sine that's less than -1 or greater than 1. So this one is not possible. So compositions, we talked about this where f of the inverse of f of x is x and the inverse of f of x is x. It was kind of our rule for inverses. This is how you verify two functions are inverses. And so the inverse property is stating that if x is between -1 and 1 and y is between those two angles, then we know these things occur. And these are fairly important. They're pretty basic, but they're important. We're going to use them. So the sine of the arc sine of x is x. Again, these are inverses, so they're undoing each other. The arc sine of y is y. Tangent, arctangent, x is x. So whenever you have the tangent and the arctangent, or arctangent, tangent, it's undoing what it's doing, so you get that y value, the inverse function. And then the same thing is true with our cosine functions as well, but we just have a different possible range. So here's the range value for the cosine, here is the range for the sine and tangent, but that inverse rule still stays the same. And so we can use those for these harder problems. So in this one, we're looking at, actually let's do the easy one down here, tangent of arctangent. Well, tangent and arctangent are inverses, so my answer is just whatever this says, 13, done. These two are a little more complicated. What we need to first do is take what's in the parenthesis here, and we need to change that into the regular trig form. So the regular trig notation will be cosine of some theta measure is equal to 2/3. So when it's written in arc cosine, the fraction, or whatever this number is the ratio. And then we need to find the angle. And we're not actually going to find the angle, but we're going to use this ratio to help us find the sine of this ratio. And that's what it's really asking, the sine of this triangle. So if I draw a triangle here, where I'm finding the cosine of theta, so cosine of this angle, and cosine is the adjacent over hypotenuse. So then I can find this other side using Pythagorean theorem. So that's going to be 9 minus 4 equals this side I'll call b squared. So that's going to be 5. So b is going to be the square root of 5. And so if I want to find the sine of this triangle, the sine of this theta measure is the opposite over hypotenuse, which is going to be root 5 over 3. So this is going to be the fraction for the sine of this arc cosine 2/3. Call that good for the night. We'll call that good